1950s, the world was trenched in the height of the Cold War. On one side, the United States and its NATO allies spread across the Atlantic, and on the other, the Soviet Union and the Eastern Bloc, both locked in an escalating arms race trying to gain the upper hand. Then, almost overnight, the battle evolved. The dangers of bombers and short-range missiles had been a threat for decades, dangers that both sides had developed elaborate countermeasures to defend against. But now, a new threat emerged with the Soviets' launch of Sputnik in 1957. Now, the threat was more real than ever. A conventional nuclear strike would take hours to deliver across continents, but now, by sticking a thermonuclear warhead atop an R-7 rocket, the Soviets could land a nuclear strike on Washington in half an hour, and the US might not even be able to get its bombers off the ground in time. The arms race had been going on for decades, but the space race was just beginning, and the US was decidedly losing. The US Air Force, fearing what would happen if they let Soviet space supremacy go uncontested, began developing plans to one-up the Soviets.
Gentlemen, this air intelligence briefing is secret.
In 1958, they commissioned the Air Force Special Weapons Center and NASA to explore the possibility of detonating a nuclear warhead on the surface of the moon. This was Project A-119. In 1945, the first nuclear bomb was detonated in the deserts outside Los Alamos, New Mexico. Not even 2 years later, Edward Teller, the father of the hydrogen bomb, began proposing a detonation test in space, and Teller wasn't the only one suggesting it. By the end of '45, support for the idea had grown, partially due to the test's scientific basis, but also because of the media stoking fears that the Russians were working on plans to do the very same thing. And if the US was going to nuke the moon, it damn better well be the first to do it. In 1958, the Air Force assembled a team to make it happen. The objectives of such a detonation were threefold: scientific, military, and political. Scientists believed that there were valuable insights into the moon and spaceflight to be made, and the Air Force wanted to test its newfound orbital capabilities. And the explosion would produce a mushroom cloud and flash of light clearly visible from Earth, an obvious show of strength to the Soviets. The 10-member team developing the project worked out of the Illinois Institute of Technology in Chicago and was led by physicist Leonard Reifel. So what did they hope to learn? Well, back in the 1950s, and especially before the moon landings, we really didn't know much about the moon, despite it being clearly visible to nearly every human ever born. Where did it come from? What was it made of? What was under its surface? Did it have a molten core? Did it have earthquakes? Could life be hiding on its surface or in its craters? Keep in mind, by this point, no living person had ever seen the dark side of the moon. Answering these questions wouldn't only tell us more about the Earth's nearest neighbor, but it could teach us about the conditions in the early solar system, and maybe even provide vital information to support a future colony. When the warhead detonated, it would throw literal tons of material into clouds above the lunar surface. Using instruments positioned high in the atmosphere or even on the lunar surface, the dust could be analyzed to determine what it, and by extension the moon, was made of. And if the blast was big enough, it could even make a hole large enough to study what was deeper under the lunar surface, under all the lunar dust deposited by millions of years of asteroid strikes. With the aid of seismographs positioned on the moon, the energy from the blast could be traced through the lunar interior, revealing details about the moon's geologic activity. And details about the moon's thermal conductivity, how quickly the moon's surface gets rid of heat from the explosion, and the possible presence of natural earthquakes could be valuable information for any future lunar colonies. Even before the first nuclear test in 1945, high-energy cosmic radiation, like the kind emitted by the sun, was well understood. High-energy particles could easily pierce through Earth's atmosphere and be detected on the ground, but low-energy radiation in space wasn't well understood. The blast could offer key insights into how radiation moves through space and how it interacts with a possible lunar magnetic field. Of great concern to the project was the possible contamination of the lunar surface. In the 1950s, as there is today, there was great uncertainty as to whether life existed elsewhere in the solar system and what it might look like. The research posed a troubling question. What if, either because of our close proximity or a tendency for life to develop in similar ways, there existed bacterial life on the lunar surface, dramatically similar to what exists here on Earth? The scientists feared that if we accidentally contaminated the lunar surface, we may never be able to know whether detected life originated on the moon or was a stowaway on a warhead or lander. Because of the moon's uniqueness as a large unweathered body in the middle of the solar system, scientific opportunities lost on the moon may not be recouped elsewhere. As December 1958 turned to January 1959, the US wised up and put a stop to the plan. Its top brass feared the negative public reaction of such a blast and what might happen if the missile missed the moon and fell back to Earth. Remember, Kerbal Space Program wouldn't be developed for another 52 years to teach them orbital trajectories. Later that year, Luna 2, the first man-made object on another world, touched down on the lunar surface. And 10 years later, Neil Armstrong would take one small step. In the end, it turned out there were more peaceful ways of studying the moon, and the Soviet Union wouldn't last forever. That's it for today on Everything Science. If you like this content, be sure to subscribe. And if you have a topic you want us to cover, make sure to leave it in the comments down below. And remember, there's always more to learn.